Now members, we are going to see how we get the median of a continuous PDF. So a median, M, is a value that divides the area under the PDF given into two equal parts. So if this is our f of x, so that area under this curve, f of x, if we get a value that divides it into two equal parts, remember the whole area under this in the PDF, say it's 1. So if we get the half of 1, it's going to be 1 over 2, 1 over 2. So if we get this value that divides this into two equal parts, then it will be our median. It means that now from A to M, then plus M to B of f of x, we interpret them, should get 1. It means that if you have to get 1 and M is the median, it means that this one is a half. From this will give us a half, and also the whole of this will give us a half if M is the median. Implying from A to M, we shall get half of this. Then also from M to B, f of x dx, we shall get half. But most people use this because let us use it also. So now, to get a median, we are sure that to get our median, we have to get from A up to f of x. The x should be equal to a half. Now, there are cases where you have two intervals, like we see in the next question, and also when you have one interval. When you have one interval, you are sure that the median is in that interval. There you don't have anything, just do in this formula. So what we do, we are looking for the value of m. So what we do is that our f of x is here for this interval, meaning the lower interval is 1. So now we shall get now from A, our h1 up to m. This is our x. The x should be giving us a half. Integrate this, we get x squared over 2 from 1 to m equaling to a half. Substituting upper limit and lower limit shall be having m squared over 2, then minus 1 over 2 equaling to a half. So when we substitute upper, we get m squared. When we substitute 1 squared is 1. There. So when you take this side, you have m squared over 2 equaling 2. Now this one doesn't cancel. Because this negative, this is positive, you take that side, you have a 1. Cross multiply, that's okay, a half plus a half, which will be a 1. Cross multiplying, our m squared will be 2. If you need m, our m will get a square root, plus or minus square root of 2. But you start, it's between 1 and 5, so meaning our x is positive. So meaning that therefore our m is root 2. Because it's from 1 and 5, so that's why we take it as a positive after getting the square root. So we have one interval, the idea is very easy. Now we have the case when we have two intervals. Now we are not sure which interval is having the median. So now the median is a small value of x. So this is the value of x in this range. So we need this value of x. So these values of x are ranging from 0 to 1. All these are ranging from 1 to 4. Now, how do we test? We start by testing. So we test using the upper limit. If this upper limit here, we substitute in this PDF, and it's that it's giving me a value greater or equal to m. I mean, greater or equal to a half. It means that will be our median will be in this range. If it doesn't, then it means that it will automatically now be in the median there. I mean the next interval there. So what we do, remember our f of x for this, our f of x is 1 over 3 over x. 4, 0, less x, less 1. Now substituting the value, the upper. So you substitute in the upper. Why? Because if you substitute in the upper to give us the biggest value of this function, and this, remember, this is continuous here. So when you put in 1, we start, we shall get a value which is less than 0.5 or less than a half. That's what I'm talking about. This one is not right. Less than a half. It's important, it's less than a half. So it means that now our median is not here. Because the value we are getting is a value which is not less than 0.5. But we say our median is the value which is going to be according to a half. Now it means that now this one means that we are now sure that it's going to be in the second interval. So when you put in 1 here still, you put here 1, you get a third. So meaning that what we do, we shall get now a third. We shall get a third. Now plus, we are sure that now it's in here. So now, this a third, we are adding it on. We put in this upper limit here. And you see that it's giving us a third which is not 0.5. So we get this, the value we have got after substituting the up. This is what we call the testing, the interval. So we put in here, we get that one now plus. Now we are sure it's going to be in here, but it's not 1 because we started substituting the 1, it's giving here a third. So it is going to be flow, it's between now 1 up to that interval and we are looking for. Although now the whole of this f of x dx equaling to a half. So when you add this and we will get the value of median, should be getting that value as a half. Simple as that. Where are we starting from 1? Because we are sure 1. So the value we want is between 1 and n. M is in here. The value we want n is in here. Okay, so this will be now. We take this side. So we shall be adding now integral from 1 to n. Our f of x now in the second interval is 1 over 9 x plus 2 dx equaling to now our half minus third. We take this side. Can you integrate? You have 1 over 9 into this will be x squared over 2 plus 2x equaling to 1 over 6. So we simplify that. So multiply through by 9. This one is from 1 up and multiply through by 9 this side, also by 9 this side. So that we shall have, put in the upper limit, m squared over 2 plus 2m, all of this. Now we are subtracting, then we put in the lower limit, it will be a half, now plus 2 equaling to 9 over 6. So here we have, allow me to cross multiply here. Okay, I have m squared plus 4m, the whole over 2 equaling to 9 over 6. Now you subtract off this. Now, plus, the whole of this is going to give us, what are we having here? The whole of this is going to give us 5 over 2. 5 over 2. As simple as that. When we take it, the other side is 0.5 and this is 2. When we take it aside, now it becomes positive. So now, this will be m squared plus 4m over 2 equaling to, what happens here? LCM is 6, 4. LCM is 6, so we have, LCM is 6, so we have 9 plus, this goes here twice. This goes here 3 times times this, you get 15. So, if I'm to use this part here, multiply through by 2, by 6, multiply through by 6, in that order. So if I multiply through by 6, I'll be having here as 6m squared. When I multiply there by 6, I'll be having that. I'm multiplying through by 6 to remove that LCM there. So when I multiply here by 6, I have 3m squared. Here by 6. Now it will be, so here I have 3 plus 4m equaling to by 6 here. We add that, we get 24. Take this side, we have 3m squared plus 12m minus 24 equaling to 0. So what happens there? We just press this on the calculator, so that we are pressing this on the calculator, so it will be minus 12 plus or minus, we use a bulldozer. B squared, so we have 12 squared minus 4 into a, then into negative 24. Now all over 3 into a. Okay, so this is 2 into a. Please you show this method because you get a mark for showing this 2 into 3. So now you get your values of n from there. And I place my calculator there. So we are getting the first n is 1.4. 641, or the other n, the next n is negative 5 point 4, 6, 4, 1. And now, because we say the value is that it's in this range, it's non-negative, so meaning that therefore our n is going to be 1.4, 6, 4, 1, that is our n. You see it's above 1 because we saw 1 can't take it. So that's how we handle the two of these ones, members. I wish you well. Okay, you're going to see more of this in the next lesson. See you.